in this lecture, we'll talk about the application of parametric equation. A rocket launched from the ground can be described by a pair of parametric equations. And x of t is v cosine theta t, and y of t is negative 16t squared plus v sine theta t, where v is the initial speed. See, this is the vector v. You threw a rocket into the sky, launched a rocket into the sky. The initial speed like that. Okay? And then theta is the angle with respect to the ground. This is theta. Okay? So for the different value of v and theta, all the movement is a parabola. But you know, the parabola may be in different shape. And down here we have a v is given is 48 feet per second. The initial speed appears two different places. Okay? And we have a theta is a nice angle, is 60 degrees. And again, theta also appears in two different places. T is everywhere. Okay? Now, T is the time. Is the time. You know, this v vector can be decomposed into the two different vectors. One is in the horizontal way, which is the adjacent of theta. Another is a vertical way, okay, which is the opposite side for this theta. Then we know that the horizontal vector is actually the vector v cosine theta. So this is how we get vector v cosine theta. That's the speed for the horizontal direction is v cosine theta. Okay, because this leg over hypotenuse is cosine theta, so this velocity will be the cosine theta times this vector. So the speed horizontally times t will be the distance at a time it's far away from the origin. Okay? And vertically, we know we cannot do that simple. V sine theta is the component in the vertical way going up, times t, because of the gravity. Okay, this is the acceleration constant, negative 16 feet per second squared. Okay, so horizontally it goes, this is the equation to describe it. The vertically, horizontally is this one. Vertically we have a gravity. That's how this equation is that. Okay, now when t equals 48 feet per second and theta equals 60 degrees, how does the parametric equation looks like? This one probably is an easy one. So we got to figure out this one first. Then we will have a x of t is v is 48 and cosine is 60 degrees, and then t. Okay, so I may put parentheses right here. And y of t we'll have a 16 t squared and then plus 48 sine theta is 60 degrees, and then times t. We know this number, cosine 60 degrees is what? Is 1/2. Sine 60 degrees is radical 3/2. Okay? Then we know we can write this parametric equation one more time, will be what? 1/2 times 48, which is 24t. Okay? And y of t is negative 16t squared. 48 times radical 3/2, that's 24 radical 3t. Okay? So then we have figured out the parametric equation. And then we need what? We need a rectangular equation. That's probably not hard. You know, the first one, both sides divided by t. Then you can cancel this t and red t. Not divided by t, by 24, Let me do by 24, okay? Divided by 24, Then you may cancel what? You may cancel this 24 with this 24. So then t stands alone on the right. Okay? So what we get will be what? Will be x divided by 24 is t, alright? Okay. Then you plug in t back here, you are done. Okay? So then y equals negative 16 times t squared. T squared is x squared times 24 squared. Okay? 24, let me split it. 24 is 4 times 6. And then it has squared, so we square it. Okay? Alright. Now, plus 24 times radical 3, and then t is x over 24, Alright, keep going. We then have is y eventually is, look, 4 squared is 16, which cancels this 16. So you then have a negative 1/6 squared, which is 36. You then have an x squared. 24 up and down, so you then have a radical 3x. Okay, so that's the solution for the rectangular equation. Alright, yeah, this is correct answer. Okay, one is this one, another it has 2. Alright, now, how long is the rocket in flight and how far it goes? You know, vertically, the rocket goes up and down. So we want to see how long is the rocket actually in sky. It reaches the ground, we know y of t is that. So y of t equals 0 means what? means the vertical distance is 0. So it reaches the ground. And then from here we have what? Negative 16 squared plus 24 radical 3t is 0. Okay. Now, if you pull t out, you then have a negative 16t plus 24 radical 3, okay, equals 0. So then you get one is t equals 0, another is negative 16 plus 24 radical 3 is 0. Okay. T is 0, we know that at the beginning the rocket was on the ground. And for this one, you subtract 24 radical 3, 24 radical 3 on both sides. You cancel this one. So what you get will be what? Will be T equals actually negative 16t. Let me write here negative 16t equals negative 24 radical 3. Okay. And you divide it by negative 16 on both sides. Okay. Then you will have a t is 24 over 16 radical 3. Okay. And then which is what? 24, 16, you can do some consolations. 4 is a common factor. You can cancel that. Okay, so 4 radical, upstairs will be 6. 6 radical 3. Downstairs is 4. You can even do more consolations. 8. So it's 3 radical 3 and the 4 downstairs is 2. So 3 radical 3 over 2. That's the exact value. Approximately, that's 2.6. You may want me to write 2.6 seconds in sky. Okay? Now, how far it can go? This is the amount of time in sky, and horizontally it will last 2.6 seconds. And this is the horizontal function, okay, x of t. So then x of t will be what? Will be 24 times 3 radical 3 over 2. Okay. You may do the consolation. Here is 1. Here will be 12. And then 12 times 3 is 36. So 36 times radical 3 is 62.3. So approximately it goes to 62.3, or if you just need to do it, 62 what? Feet. Okay? That's it. I'll see you next time.